Hey guys, we're going to be talking about writing and solving absolute value inequalities. Sorry, I just kind of scratched that out. So I know, for example, like the absolute value of 5 is 5, and the absolute value of negative 7 is 7. Like you guys know that stuff. The definition of an absolute value is its distance from 0. So for example, when we have 5, that the reason the absolute value of 5 is that this value right here is 5, the distance traveled. That's why I said distance from 0. Same thing of this one, 1, 2, 3, 4, 5, 6, 7. That's why this is 7 and not negative 7, because the distance covered is 7, right? Right. So then now this problem gets a little interesting because you're going to find out it's not the distance from 0 on this one. And so here's how I want to do this first one. I just want us to guess and check, because we can pretty much guess and check. So what I mean is, like, what number do you know that when you subtract 5 are you going to get 7? Well, okay, 12. We know that 12 is one of those answers. So here's 12. And then also we could pretty much tell, like, negative 2, because negative 2 minus 5 is the absolute value of negative 7, which would be 7. So when I said that the distance from these would not be the distance from 0, I mean, you can clearly see 0 is not right in the middle. This entire distance is 14. And what's right in the middle of them, even though my picture's a little skewed, it's 5. And if you're like, wait, how's it skewed? It's not perfectly drawn. Like, I don't know, 5 might be a little bit more right there on a truer number line, a better looking number line, right? Anyway, so from here to here is 7, and from here to here, I'm sorry, from there to there, well, yeah, no, I was right. From there to there is 7, from there to there is 7, and 5 is in the middle. So what about the distance from 0? Well, what's interesting about this is it's the distance from 5, right? And what's interesting about that is you might look at this and say, oh, well, that's a negative. Shouldn't that be negative 5? Or, oh, wait, that's a negative 5, but this is an absolute value. So, of course, it's positive 5. Well, hang on. Before you jump on that, why don't we try the exact same problem, but now the 5 is no longer negative. The 5 is positive. So we're going to do the same exact approach. And don't worry, we're not going to do that approach on all of these. We're doing it on this, though, just to kind of get a handle on kind of the uniqueness of this. So what number plus 5 is 7? Well, how about 2? 2 plus 5 is 7, sure. And then how about the other one is negative 12 plus 5? You might already kind of see a little bit of like, wait a second, that's the opposite of what we had up here. I don't know if you necessarily saw that, but hey, maybe you did. That'd be cool. So here's 2, and maybe to try and make this truer, I'll count negative 12, 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. Cool. So here's negative 12. Here's 2. And the distance between these two, just like the last one, is 14. That shouldn't blow your mind too much because, like I said, the only difference between this one and this one is the fact that we changed that to a plus sign that was a minus sign there, right? And then what's going to be in the dead center? Do you know? Well, what is 7 away from 12? So 11, 10, 9, 8, 7, 6. Negative 5 is in the dead center of that. Sorry, that distance right there is 7. Guess what? This distance is 7 because it's, half of 14. And boom, right there is negative 5. So wait a second. Again, I said that this thing is about the distance from 0, but that was pretty much our most basic version of absolute value. This is not the most basic version. I mean, this isn't a full equation. We've got absolute value of x and something. We're not just doing the absolute value of a plain old number like right here, right? Now, we will get into this later, but we will eventually talk about that this is a parent function, the absolute value of x. Hang on, I shouldn't have written that one first. that right there is a parent function, and it looks like this. Pretty much looks like this. Not exactly what you were expecting, I'm guessing. But you already know that this thing produces positive numbers. So when you plug in a 2, well, then you should get 2. You plug in 3, you should get 3. But what about when you plug in -2, you should get 2. You plug in -3, you get positive 3, right? So that kind of makes sense, right? And then this is where things get, obviously, things are going on here, right? This is moving things left and right, up and down, changing the slope. So when we look at this, check it out. How far did this one move from 0? It moved 5. Okay. How far did this one move from 0? It moved also 5. Interesting, though, that the -5 moved to the right and the +5 moved left. This is the last thing I'm going to say about this over here. If you look at this equation right here, this explains it. When you plug in a negative to -h, you end up getting a positive. So check it out. When we had that positive right here, it actually moved it to the negative. I know, little, maybe more than you wanted to bite off and chew on right there, but that's in the future, and I think it's pretty interesting, pretty cool looking. It kind of makes me feel like a math superhero that, you can look at that thing. You can look at this and know what the heck you're talking about. Feels a little crazy, doesn't it? And you will. You'll be able to do that. It'll be awesome. So let's do this, and now let's actually solve one of these for real. Now, I'm going to go ahead and just tell you the method. You're going to have one positive version and one negative version. Okay? And if you're like, what does that mean? Well, kind of like this, what's one? The absolute value of 5 is 5, but the absolute value of -5 is 5. So it's like you could say that's the positive and this is the negative, right? So check this out. I'm going to start with the positive. In fact, here's what I'll do. I will make positive red. I'll make negative blue. I'm thinking of like temperatures. This is the heat going up. This is the heat going down. All right, so here we go. The positive version will look like this. Notice any big differences between this and the positive version? Well, all we did was drop the absolute values. So now let's check out the negative version. So a little different, little more change to it. This dropped the absolute value, so did this. This is the exact same. This is now negative. Hopefully you can see why that's the negative version, right? And now you just solve this like normal. Add 2 to both sides. Divide by 2. X is 6 is one of the answers. Add 2 on this. You get -8. Divide by 2, you get -4. That's the other answer. So if you think about it, when we take this and we plug it in, 2 times 6 is 12. 12 minus 2 is 10. The absolute value of 10 is 10. -4. 2 times -4 is -8. -8 minus 2 is -10. And the absolute value of -10 is 10. Now, I'm going to graph this, but until we get to an inequality, I'm not going to graph any of these anymore because we just don't really care about the graph. That might sound a little strange, but, boom, there's that. And if you're like, well, okay, I kind of care because of that whole distance from 0 thing. Well, okay, here's the overall distance. It's 10. Okay. And you might be thinking, well, wait, why is that one 10? And, the others were whatever. Don't worry about it, okay? Yeah, so here we go. The middle of it, let me pick a color I like, is 1. And it has to do with that, okay? So, and then each of those distances is 5 apart. So, there you go. This part is what you need to know. This part is what you need to know, okay? Let's do this next one right here. we're going to have a positive version. We're going to have a negative version. Remember, all we're doing is dropping the absolute values, having that one be positive, having that one just be copy-paste, and then one of them is negative, okay? So add 3, divide by 3, x is 6. Add 3, divide by 3, we're done. Now, one other thing I want to say, and I'm going to zoom out because it has to do with this one, and I'm going to write it out right here, is that get the absolute value alone before you do that stuff, okay? Get the absolute value alone before you do this stuff, all right? And if you're like, I don't know what that means. Well, right now, our absolute value is right here, and our variables inside of it. I mean, if it were just the absolute value of 2 or 3, we would just produce a number, but we don't have that. So what we're going to do is subtract 4. And, whoops, I slid over. We get the absolute value of 2x equals 4. You know, because 8 minus 4 is 4. Now you do a positive version. And you do a negative version. Not that crazy, huh? This one becomes x equals 2. This one becomes x equals negative 2. And that's it. We're done. Now let's zip up here because just like the other ones, we're going to have a positive version and a negative version. But I have just thrown you a curveball. Do you see it? Pause until you see it. Okay. This and this and this and this, all identical. What about that? Oh, and I forgot my negative. So, 2 differences. Greater than, less than. When you do the negative version, you flip the inequality. So you had reasons before to flip the inequality. You would flip the inequality when you multiplied or divided by a negative, right? But so that was 2 examples, like 1 and 2. Now the third example is when you flip it when you do the negative absolute value. Right? Right. So here's what that's going to look like. X is less than 13. Easy. X is greater than negative 5. We have to graph it now. Notice I said earlier, we're not going to graph these anymore. Well, I didn't tell the truth completely because when it comes to inequalities, you graph them because there's more than one solution. With these two, okay, yes, those are more than one solution, but I mean there's exactly 2. With this, there are tons and tons of solutions, right? So the first one, here I'll do the red one first. 0, 13, open circle, and we shade left. Blue one is at negative 9, open, oh, not negative 9, negative 5, open circle, and we shared to the right because it's greater than. So here's the question. Is the answer all real numbers? Because we just shaded the entire line, right? Like this red one overlaps the blue part, and this blue part overlaps the red part. So is it all real numbers? Or, well, it's funny I said or, because is it that you remember compound inequalities? You can have an and, or you can have an or. Well, this one is an and, okay? It's an and because of this overlapping region. So like the true graphical answer to this problem is like this. Negative 5, 0, 13, open, open, shade right here. That's like the true graphical answer. So here I'm gonna like connect those with arrows. This is an and, like I said, and one way you can kind of know that is you can, well, graph it. Another way you can kind of know that is If you tried to combine these into a compound inequality, it would look like this. Negative 5 is less than x. By the way, that's just this one flipped around. And then we keep going. That's less than 13, which that's not even this flipped around. That's just copy pasted right there, right? This is what an and looks like. Yeah? If this were an or, it would not follow that format. They'd be going different directions and things like that. And then last but not least is my favorite way to kind of remember or know ahead of time that this is an and, is this right here. This is a less than sign, right? But here's what I'm going to do instead. I'm going to call it less than. I'm going to pretend I have a cold, and so I would say this is a less than sign. So yeah, less than. It's stupid, I know, but it helps me to know in the future what it should look like, and that's something that's kind of important to us. So does my stupid example go beyond that? Yes, it does. This is a greater than sign, which you could also read it as greater. It's a greater than sign. So what does that mean is that our graph will look something like this. That's what an or looks like. So let's do our positive and negative versions because our absolute value is already by itself. X minus 7 is greater than or equal to 9. Our negative version, do you remember that you will flip the inequality symbol? Hopefully you do remember that. I add 7, I get 16. I add 7, I get negative 2. And really, here's what I'm going to do. I'm just going to go over here and write those numbers. There's 0. Here's negative 2. Here's 16. This is a filled-in circle, and it's all of the numbers that are greater than 16. This is a filled-in circle, and it's all the numbers that are smaller than negative 2. And that is perfectly an or. And remember how I said if you tried to write an or like this, you would fail? Yeah, that's what's going to happen. And if you're like, wait, how do I know it fails? This one is always smaller number, bigger number, right? That's just how number lines work. So here's the one that would work. You could have 3 is less than x, which is less than 99. Notice that follows the smaller number on the left, the bigger number on the right. You could do negative 99 is less than x, which is less than negative 3. That messes with your head a little bit because of negative numbers, but negative 99 is smaller than negative 3, right? Right. So same thing if we tried to do this. So we would put the smaller number on the right, on the left, but this thing flips around, right? To follow and make sure we're doing this correctly. Because this little alligator is eating the negative 2. So there's the x, and okay, well now this guy is eating this way. Okay, that doesn't follow this. You know what I mean? So anyway, that, just letting you know that's why that messes up. And that's the answer to that. And now let's do the last two. The absolute value of x plus 4 equals negative 9. Our absolute value is not by itself yet. So we need to subtract 4. And here's where we have an interesting situation. There's no solution to this problem. Because think of a number you could plug in here to get the result of negative 13. Okay, well, what about the absolute value of negative 13? No, that would be positive 13. There's no number you can plug into an absolute value that will produce a negative number, right? Of course, I hear you saying, well, what if there's a negative out front? Yeah, well, then our absolute value is not by itself if there's a negative out front, right? So it doesn't really work. So this is no solution. Math people, we love to kind of give some crazy looking math problems that end in no solution. So kind of keep your eye out for if your absolute value equals a negative. You know what I mean? Okay, so speaking of crazy looking ones, this one's not, it's crazier looking, but I'm guaranteeing you it's not no solution, okay? Our absolute value is not by itself. So here's what I'm gonna do. I'm gonna subtract 10. And I have negative 2 times the absolute value of 2x plus 4. By the way, I know this is a little silly, but I always try and draw my absolute value bars kind of exaggeratedly long. Maybe I could have phrased that better. Anyway, just so that I don't mix up what they are. Like, there's no chance of it being a 1. You know what I mean? Negative 16. And now, one of the reasons why we're doing this is you get to see that we're going to divide by negative 2. I wanted you to see that this thing and this thing, you can do that. We haven't really done that before. Not on a problem like this, so now you at least see that, oh, that's what that looks like. And you're going to flip your inequality. Why? Well, because you multiplied or divide by a negative, so that's one reason why you flip it. All right, now we get to drop the absolute values because we have the positive version, and we're going to have the negative version. Let's solve. Subtract 4, divide by 2, subtract 4. Hold up, where did I get that? There shouldn't be an equal to part right here. My bad. Okay. Back to this. 2x greater than 12. No. So here's what I did. I interrupted myself, trying to make sure I was getting all my details, and I got that detail wrong. Okay. Minus 4 is negative 12. Divide by 2, x is greater than negative 6. No, I did not need to flip anything on this one because I divided by a positive 2, right? All right. So let's graph. This is our number line. There's a 0. There's a 2. There's a negative 6. Open circle all the numbers that are greater than negative 6. There's the 2. It's an open circle. All the numbers that are less than 2. Oh no, is it all real numbers? Or is this... Oh no, this is a greater. But it's not. The absolute value was not by itself yet. Let's zoom in here where the absolute value is by itself. And this is a less than. Now, my handwriting's terrible, but hopefully you heard the words. This is a less than. So technically the answer is just here to here like that. So you now can graph and write and solve absolute value inequalities. Let me know what questions you got.